Hi, this is one of our wrecking bars, and it's a product that we are very proud of. And one of the reasons is that the ends are thin enough for nail pulling and getting access into narrow spaces, but at the same time it's strong and ductile enough to deliver a lot of force without breaking. Other manufacturers might make wrecking bars that are strong enough, but if you take a look at this one, it's also a lot thicker, making it a lot harder to work with. The real challenge here is making a wrecking bar that is strong and ductile and still thin enough at the same time. One of our competitors have wrecking bars that looks quite a lot like ours, and we actually painted these to disguise the brand a little bit. But since they look so much like ours, we wanted to test them and see how they measured up. So we took a bunch of their wrecking bars and we took a bunch of our wrecking bars and we tested them alongside each other. The wrecking bars were clamped down in one end, and then we applied a force and started bending them. As you can see, the claw of our wrecking bar starts to bend when the force becomes too high. That might seem like a bad thing, but it's actually great if you consider the alternative, which is a wrecking bar that breaks. Not all of them, but quite a large proportion of the competitors' wrecking bars broke off when the load became too high. And this can be very dangerous. Imagine that you're pulling on this with your entire weight and then it snaps off. That can send you tumbling into all kinds of dangerous things in your surrounding environment. Even more dangerous than that, perhaps, are these small metal splinters that form when the wrecking bar breaks. They can come flying at you at a very high speed, and they can injure you, your colleagues, or the surrounding environment severely if you are hit by one. It's also interesting to compare the forces involved. In some cases, the competitors' wrecking bars will break at far lower loads than what is required just to start to plastically deform ours. And some of them are too soft and will plastically deform at very small forces. It's hard to say exactly why there is such a big difference between ours and these. And that is because we cannot say anything about the raw material or the production process that goes into making these ones. What we can say, however, is that we use Swedish boron steel when we manufacture our wrecking bars. That means that the steel is alloyed with boron. Boron is a metalloid that gives us a stable and predictable behavior during the quench hardening process, and it also gives us an increased resistance to wear and impacts. We also know that the process of forging, hardening and annealing a wrecking bar like this is a very difficult process that we have spent a lot of time and effort on mastering. So we're not surprised to see that a competitor that's quite new to this is struggling to get the quality right. We were, however, a little bit surprised to see that the difference was so big. In the end, it's nice to see that all the time and effort that we have put into mastering the production process of these really has paid off, and now we can confidently say that you probably cannot find a better wrecking bar than a Hultafors wrecking bar.